Welcome to Firewise in the Classroom, Chapter 6, the Public Land Survey System. Make sure that you have Chapter 6 in your Student User Guide open now. The lands that make up the United States were not all acquired at one time. There were numerous agreements, as you can see here. The lands that make up Minnesota actually were the result of 3 separate land agreements. Commonly, in order to be able to describe and map the land, a system called meets and bounds had been used. And this was measuring from things on the landscape like trees or rocks or rivers or creeks, and using compass directions to be able to make a description. The problem with this is that the plots that were measured were typically irregular. They were hard to find the boundary lines, they were hard to navigate, and it was nearly impossible to describe to someone exactly how to get somewhere easily without a very long written text. That's why the Public Land Survey System was created. PLSS divided newly acquired lands in the United States into easy-to-find and standard-sized parcels. These parcels were sold by the federal government to generate revenue. The PLSS was first developed in 1796. Take a few minutes and pause the video to answer the first 3 questions of your student guide. Minnesota was surveyed from 1848 until 1857. We became a state in 1858. The job of putting a grid over the entire western and central United States was a very big one, and we had to start with some anchor points or some places where crews would be able to draw uniform cells north and west of those anchor points. You'll see here in Minnesota, there were actually 2 surveys that were conducted, one in green and one in yellow. If we take a closer look, you'll notice that the survey conducted in yellow has a north-south line that goes through the tip of the arrowhead called the 4th principal meridian. This was an area that had a survey mistake that we'll talk about in a few minutes. It's still easily visible in all of our survey work today. The core of the PLSS are township and ranges. A township is a 6-mile by 6-mile box that is further subdivided into 36 1-mile by 1-mile sections. This is how we describe land, with a township number, a range number, and a section number. The survey crews that worked across Minnesota were not just comprised of men. There were women on crews as well. Crews were typically local folks, but they were agreeing to be gone for months, if not years at a time. They had to carry all of their work gear, which was very heavy, very bulky, as well as everything they needed to live off the land. They worked in all seasons, literally walking across the state of Minnesota. Now you'll watch a short video on the history of surveying in Minnesota.
These are the men who mapped Minnesota. Faces largely lost to time, but their work still has a profound impact on how we live today. To learn their story, you need the help of a historian. In this case, Charles Rogers, the government records specialist at the Minnesota Historical Society. Where are you taking us, Charlie?
I'm taking you to the archive storage room.
Okay.
This is the largest storage space in the building.
Oh, wow. Yeah, this is a big room. So what's in here? Cardboard boxes, obviously, but what's in all the boxes?
Cardboard boxes full of just paper records, state archives as well as non-government records, as well as the original land survey plats that were done by government surveyors over 100 years ago. And all of our property rights or our land rights are based on that original survey.
So paint me a picture as to what life was like for these survey crews. I mean, 1857, wasn't even a state yet. There's not a lot of infrastructure. You can't stop at McDonald's on your way out to do your work. What was their life like down here making this grid?
Well, they were actually usually local people, local men that were hired under contract by the U.S. government. And they were basically out there on their own, camping out. Like you said, there was no McDonald's. They had to pack everything in and pack it out. They had to take an oath to do honest, good work.
Oh, right here, this is one of the oaths. Chainman, I, Edward O'Brien, do solemnly swear that I will faithfully execute the duties of chain carrier. Boy, this is a specific oath. Mm-hmm. According to the logbooks, each field crew had highly differentiated tasks: chainman, flagman, deputy surveyor, and more. It was their job to physically mark the landscape, sometimes by driving rails, and sometimes by inscribing actual living trees. Now, is it true that some of those trees that they marked are still out there and alive in Minnesota today?
That's true. There are a few of those trees, what they call a bearing tree, that are still in existence here 150 years after the survey was done.
Well, that's all I needed to hear. I want to find a living bearing tree. Which takes us next to Craig Hinsman, a Ramsey County surveyor who recently made a discovery. Now, you were telling me on the phone this tree right here is a pretty significant one?
This is a very significant tree. It's a U.S. government bearing tree that we identified this winter.
Turns out, about 50 years after the initial survey effort, Ramsey County installed more permanent stone markers. And by reconciling these landmarks with the logbooks back at the History Center, the original bearing trees can be located. Craig and his team demonstrate.
This is the chain.
And this is not a modern thing. This is the historical version of what the actual survey crews were using?
This is a replica.
A replica, okay.
Yeah.
This looks pretty straightforward overall. You each grab a handle on either end, just yank it tight. Now it looks like Dan's using the plumb line to make sure that he's starting from exactly the same point again.
Yes.
From that little scuff in the concrete, you line it up and then you have just the right number of links. That's incredible, you guys.
Right there.
And it takes us right to the tree, and that's how you can confirm this is a bearing tree. So really, after 100 plus years of healing, you do not see a lot of external markings. You gotta use the records to find your tree. You can't eyeball it from a distance.
Correct, yep.
So if you saw the marking tree back in 1860 or whenever it was originally marked, it would be very clearly lettered and numbered and would look like an official marker?
Yeah, you would be able to read the writing and the scribing.
And if we were to cut down this oak tree, which we're not going to do, but if we were to chop this one down, go in about a foot deep, you're guessing we'd see something like this?
Yes.
Once a bearing tree is found, its position is carefully recorded. It looks sort of like a treasure map, doesn't it? And now, just because I asked politely, Craig gave us a map of our own, which led us north to Burwood Park in Vadnais Heights. That's right. Luckily, we were given very specific directions. We knew the distance from a contemporary intersection and even the size and species of the tree. At this point, it was just a matter of finding a match, and it didn't take long. Now, based on our description, this has got to be the right tree. We're almost 240 feet south of the intersection and 50 feet west, and this is the only large oak in the entire park. And the scar is not distinct, but I think it's this one right here, because this band continues all the way down. And you have to remember, this tree's had over 100 years to heal at this point, so you're not going to see a lot. And that's really the incredible story here. You have to imagine, over 100 years ago, these crews trudging through the Minnesota wilderness, and when they find an intersection point, they gouge their mark into a tree like this. And now here we are a century later, and you can still see their handiwork. It's pretty incredible.
This is an example of the PLSS Grid across northwestern Minnesota. Canada is the northern boundary, and North Dakota there along the river to the west. You'll see that not every township is a perfect 6-mile by 6-mile rectangle. If there were natural border features, like a river, that were created, or man-made border features, like the border with Canada, those are places where the township shape would change. You'll also notice around the middle of the screen between Township 160 and 161 that there is a shift in the squares. They don't all line up. We'll talk about why that's necessary in a few minutes. Again, this is what a township looks like. It's comprised of 36 1-mile by 1-mile sections. Those 1-mile by 1-mile sections can then be further subdivided into quarters or quarter quarters. We then tack on the NW, SW, SE, and type variations to the end of the name to describe those smaller portions of the parcel. There was an interesting survey issue in northeastern Minnesota around the Arrowhead. It happened along the 4th principal meridian, which was the starting line for surveys. One survey crew started from the line and headed west. Another survey crew started from the line and headed east. The problem was they used the same naming convention, and so you'll see that along the line there are 2 different townships sharing the same name. That becomes very confusing for people trying to navigate to or purchase land. The solution for this was to add either a W for west or E for east to the end of the township descriptions. Think back to a few minutes ago, we talked about not all of the grid cells were completely aligned. There's always a problem when you're trying to create a 2D or uniform map that's covering a 3D or not uniform. The Earth is neither completely round nor completely uniform. You can see here in this topography 3D map of places that are higher or lower or maybe a bit misshapen, not completely round. This poses a problem when you're trying to draw a very uniform grid that's representing a not very uniform 3D object. Let's take a look at this problem for yourself. Take a blank sheet of paper, 8.5 by 11, notebook sized, and draw a township on it. That's 6 columns and 6 rows. Pause the video if you need to. Now find a round object, maybe a piece of fruit or a tennis ball, and try to wrap your paper around it. What happens? There's no way that the squares that you drew can cover the round object without somehow being folded or pinched or torn. You could do the same experiment with silly putty or Play-Doh. Roll the dough out flat and then try to wrap it evenly around the round object. There's no way that you can accurately represent the grid everywhere on the map. The same thing happens with PLSS. There are places where the grid had to be adjusted to reflect the landscape. You'll notice this later on when we use GIS when you're zooming in to particular townships. For instance, the corners here don't line up. This is the end of Chapter 6, the Public Land Survey System.